Okay, we're going to look at some misconceptions to do with multiplying and dividing. So, let's first of all look at some obvious rules that you'll know off by heart. So, I bet you know that if I've got a number and I times it by a number, add a number in brackets, then I can just expand and get a times b plus a times c. So, for example, 2 lots of x add 1 would give you 2x add 2. Now, the biggest misconception of this is people always forget to multiply this last bit as well. So we'll just leave it like that. So 2x add 1, that's not equal to it anymore. So the case where I see this the most is if you have an equation of a line or something like this, y equals a half x add, let's say 5, then I'm going to do this in red because it's incorrect. What lots of people do is see the half, think, right, I need to get rid of the half by times by 2. So the answer is 2y add x plus 5. Sorry, equals x plus 5. Yeah, another mistake within a mistake. But what we should have done here is you're correct to get rid of the half times by 2. But when I'm timesing an equation or an identity like this, I need to do the same thing to both sides. So I times this side by 2. And at times this side by 2. And again, since I'm writing in blue, you might not necessarily write this working out when you're doing it. So this side becomes 2 times y is 2y. And this side expands, so 2 times half x gives me 1x. And 2 times 5 gives me 10. So it should have been 2y equals x add 10. Okay. Next one is, again, if I've got a number and I times it by 2 numbers that are already times together, then the end of that is just all 3 times together. Or equally, I could have done the first times there and then times by the second one. So for example, if I want to do something like 2 times 5 times 20, to do that, I could first do 2 times 5 is 10, and then times that by 20. Or I could do 2 times 20 first, and then times that by 5. It doesn't matter what order I do things in. But what I don't do is I don't do 2 times 5 and 2 times 20, and then times them together. I don't expand both of them, if that makes sense. Since these are all terms, multiplying, I just do in any order. So 2 times 5 times 20, or 2 times 20 times 5. I don't do 2 times 5 times 2 times 20. There's no add in the middle, so I don't have to expand that bracket. And why I see this the most, so the misconception comes about again with lines, when we use the y minus y1 formula. So we've got y minus half is like 3x plus 1, something like that. Now, you might think, right, to get rid of the half, I can times it by 2. So I'm going to write down here what mistake I see. So when people times this half by 2, they've now understood it should be 2y minus 1. And when they times this half by 2, what they do is they do 3 times 2 is 6. And this times 2 is 2x add 2. Now, what I didn't need to do is we didn't need to times both these things by 2. So if I show you using blue mathematically what's happening, so times this side by 2. So you times this side by 2. So you're right, this side becomes 2y minus 1. But this side, look, it's 3 things times together. So I can't do them in any order. So I can either write it as 6x plus 1. That's probably the best way to write it. Or if I wanted to, I could do the 2 times x plus 1 and keep the 3 on the outside. So I could write it as the 3 2x plus 2. What I don't do is I don't have both these. I don't have the 6 and the 2x plus 2. Just one of them. Okay, the next misconception, I'll give you the numerical example first. It's something like this. 5 times x over 2. Yeah, you'd be surprised how many people write 5x with it. If I'm timesing a fraction, what I do, so if it's like a times b over c, I just times the top, like that. And if it makes it easy to see why, I'm just going to put 1 at the bottom, and hopefully you should be able to spot that very quickly. Okay, now let's look at a bit of dividing. Well, the first thing I want you to think about before doing any dividing is something like a over b. What that really means, that means a times 1 over b. So if we can change a divide into a times, then we can use all the rules you just done with times in. So for example, something like this, a plus b divided by c, well, that's the same as 1 over c times a plus b. Divided by c is the same as times by 1 over c. Then we can expand that as before. So 1 over c times a, so a over c plus 1 over c times b, so b over c. Yeah, so essentially what I can do is I can split this fraction up. Look, so if I have something like, let's do the numerical example, x plus 6 over 2, I can do that as x over 2 plus 6 over 2, which is 3. Yeah, but again, what I see lots of people doing is to see the 2 and the 6 and think, right, I can write that as x plus 3. But I need to divide both of these by 2, because what I'm doing is I'm expanding by a half. So I'm doing half times x and a half times 6. Okay, the next common mistake I see with dividing is the opposite of that. So I'll give you the mistake this time. I see lots of people doing something like this. 2 over x plus 1, and they write that as 2 over x plus 2 over 1. Now, unfortunately, if it's on the bottom like this, we can't split it up like this because I'm dividing, and here's a hint, with fractions, kind of put brackets around the top and the bottom. So I'm dividing by x plus 1. So that's the same thing as 2 times 1 over x plus 1, which again, there's no way of getting from that to that. There's no way of splitting this fraction up. Okay. The next one is something that comes up when you work out stuff like area of triangles. If I've got, I'll give you the algebra version first, times b over c. I can do that. It's either a over c times b, or b over c times a, or I can do ab and then times that by 1 over c. There are lots of different ways of doing that. So for example, if I'm doing something like 14 times, I don't know, 15 divided by 7, I don't necessarily need to do 14 times 15 first. I can do 14 divided by 7 first and get 2, and then times it by 15 to get 30. Much quicker than doing 14 times 15, then dividing by 7. And that's all because this really means 14 times 15 times 1 over 7. So we can pair up the 14 and 1 over 7 to get the 2, and times by the 15. And it's the same thing as stuff like this. If you have something like 15 times 31 over 30, again, you might be tempted to times 31 by 15 and put it over 30, but you can think of this as 15 over 30 times 31, and 15 over 30 is a half, so half times 31 just gives us 31 over 2. And again, that's because that's 15 times 31 times 1 over 30. So I compare these two because they've got common factors. Okay, the next thing to do with dividing is reciprocals. So, for example, if I had something like 1 over x plus 1 over y equals 5, you might be tempted to tell me that x plus y equals 1 over 5 by doing the reciprocal of this, reciprocal of this, and reciprocal of this. But remember, I can only do the same thing to both sides. So I can do, what I'm allowed to do is I'm allowed to do 1 over this side equals 1 over this side. This is true mathematically, but it doesn't really help because it's got fractions on fractions to mess. So something like this, I guess the best way to do it would just start off by timesing both sides by xy to get rid of both those fractions. Okay, times both sides by xy. Okay, and the last thing with fractions is just what happens when you divide fractions and fractions. So if I have something like 5 over 7, and then I divide that by 2. Well, again, I see lots of different things. I see this get divided by 2. I see this get times by 2. Whereas all that means if I'm dividing by 2, the bottom is going to get bigger. So I'm going to times the bottom by 2, so it's going to be 14. And if it helps, think of it as this, divided by 2. So I'm going to flip that, do the reciprocal. So dividing by 2 is the same as times it by half. So it's 5 over 7 times 1 over 2. And then the other one is if I had 5 divided by 2 over 7. So this time I'm dividing by a fraction. So again, what I would do here is I would times the top by 7, times the bottom by 7. So the fraction is still going to be the same answer. Now, I times by 7 so that these would cancel out. So on the bottom, we just get 2, and on the top, we just get 35. And again, it's because if I'm dividing by number, that's the same as timesing by its reciprocal. So I get back to this, which again, 5 times 7 is 35, so 35 over 2.